This is my test tube stand, a little thing I made years ago that you might catch sight of in some of my other videos. It also happens to be one of the worst things I've ever made, and can hardly hold itself together. The only thing expected of a test tube stand is to be able to stand, which makes it especially shameful that this thing can hardly even do that. I'd really like to make a better stand that won't threaten to spill chemicals everywhere, and will hopefully be nicer to look at, and I thought it would be fun to make a quick video documenting the process. After splitting some wood into planks with a froe, I knock off the high points with a draw knife to prep the wood for the plane. This block is going to be made into the pillars of the stand. I'd really like the stand to fit in amongst the other reproduction chemical and alchemical equipment we make on this channel. So I'm making these pillars a decent amount thicker than they need to be, so that I can carve some decorative facets into them for a sort of 19th century look. Once everything's nice and flat, I'm left with three pieces: a square block for the pillars, a narrow plank, which will become the rack, and a larger plank, which will become the base. I sawed the pillar block in half, and then I carefully marked off where the capital and base of our little columns will be. The height of these pillars is important, as if we make them too tall, short test tubes might fall right out of the stand. But we also don't want them to be too short, as if the rack sits too low, it might obstruct our view of the fluids in the tubes. Because most of the tests a rack of test tubes are useful for are visual ones, like telling the difference in color between two samples after adding a test reagent, we want to be able to see as much of the tube as possible. So I decided to make the distance between the base plank and the rack plank about 3.5 inches. The rest of the pillars are marked off to be made into tenons that will join the pillars to the rest of the project. I'm going to save these offcuts aside, as they're just the right size to make the tenon keys out of. Unlike the upper tenons that can really be any size, these lower tenons that will be joined to the base have to end abruptly and sit flush with the bottom of the stand for everything to be stable. So I made them shorter, and instead of having a key, I'll just drive a pin through them. With the tenons roughed out, it's time to cut out some decorative curves to make the pillars pretty. In order to preserve as many of my guidelines as possible, I only cut halfway on each side for all the sides, before turning the part around and cutting out the curves. The better I'm able to keep to my guidelines, the more parallel the walls of my little columns will be. A needle file will remove the saw marks, but I'll come back through with sandpaper when it comes time to stain the stand. The earliest examples of test tube stands I could find in the collections of science history museums were from the mid-19th century. This stand isn't based directly off any individual example, but does combine a lot of the common features I came across, and I'll link to some of my favorites in the description. I wasn't able to find earlier examples than the 19th century, though I did find a depiction of something that looks quite a bit like a test tube stand in the illustrative plates of Antoine Lavoisier's Elements of Chemistry, which was written in the late 18th century. In the text, however, this stand is referred to in the context of filtration, as a stand for holding multiple funnels to perform multiple filtrations at once, with no mention of anything like a test tube. Lavoisier does frequently make use of small chemical vessels, but often these are either small round flasks, such as the matras, or glasses that can stand on their own. This made me wonder when exactly test tubes came into use. I came across a web article written by Jess Romeo, which I'll link to below, that attributes the invention of the test tube itself to none other than the 19th century chemist Johannes Jacob Berzelius, who some viewers might remember as one of the chemists who beat Humphrey Davy to isolating the first alkaline earth metal. Her source for this is an essay written by Catherine M. Jackson, titled The Wonderful Properties of Glass, that looks at what Jackson calls the glassware revolution of the 19th century. Jackson found what she attributes as being the invention of the test tube in Berzelius's Experiments to Determine the Definite Proportions in which the Elements of Organic Nature are Combined, a paper by the eminent chemist that was published in the 4th volume of the Annals of Philosophy in 1814. That volume of the Annals of Philosophy can be found on the Internet Archive, and I'll link to it below for those interested. Berzelius's entry is a really phenomenal example of early 19th century organic chemistry. At that time, chemists around the world were all racing to identify the molecular makeup of as many organic compounds as they could, and were constantly inventing new methods to do so. Berzelius's method, outlined in his entry to the Annals of Philosophy, involved filling a glass tube that's been sealed off on one end with the organic matter to be analyzed, along with a bunch of potassium chlorate, a potent oxidizer, to help absolutely obliterate it and burn it up entirely into carbon dioxide and water, which was then collected and weighed to determine the amount of carbon and hydrogen in the sample. These glass tubes were called combustion tubes, and were handy to have around. The tubes make their way into later analytical tools, like Justus Liebig's Kali-apparat. Their small size makes them less likely to suffer from thermal shock than larger glassware, making them safer to heat. It also means they're nice and cheap, and could be made on demand by the chemist with their own blow lamp. Most examples I could find of test tube stands from the 19th century had an even number of tubes, with the vast majority having space for 6 tubes. I'm not sure exactly why this is, but I don't think it's a coincidence. My thinking is that 6 tubes allows for 3 sets of 2, which seems like an intentional proportion for the sake that 3 trials, each with their own control, could all be compared to one another at once. That said, I can't help but notice that Lavoisier's filter stand also had exactly 6 holes. It's possible chemists just started using filter stands to hold their test tubes, and the design stuck well after they began making dedicated test tube stands. But if anyone has any better idea why this may be the case, feel free to comment below. I used the end of a drill bit to put dimples in the base, directly below each hole. That way the ends of the tubes will have a place to sit, which should help keep them nice and stable. After a bit of final sanding, I gave the stand a coat of walnut stain. Finally, the stand is assembled and rubbed down with a bit of boiled linseed oil. Once dry, the stand is ready for use. Luckily, unlike my old stand, this new rack is able to stand still without falling apart. It genuinely lives up to its name as a stand. It may be one of the sturdiest things I've ever built, and personally, I think it looks right at home in the lab. Thanks for watching. I hope you enjoyed this video. It was a bit of an experiment in making a shorter video in between the longer ones, so it would mean a lot to me if you'd let me know what you think down below, and if you enjoyed this kind of quick look at one of the often forgotten pieces of kit that goes into a functional laboratory. Your feedback is always really helpful in making these videos, And as always, if you have any questions, comments, or corrections, please feel free to comment below. Thanks again, and happy testing!